Welcome to Physics Class 3. Here today we want to learn an important topic in electric field. We have a capacitance and a capacitor. So let us quickly understand this concept. So before we can go into calculations involving capacitance and a capacitor. Now, what is capacitance and capacitor? Now, from the word capacitor, we can derive a capacitance. All right. So one is an adjective and one is a noun. Okay. Now, let us look at electrical field. In electric field, we want to store electric charges. A device is required in order for us to keep these electrical charges. In electric field, we have opposite charges. We have the positive and the negative charges. So a device that is used for storing these charges is called a capacitor. So now, capacitance or capacity is a property of what? An electric field. Capacitance or capacity is the property of an electric field whereby a charge is given toward a conductor to produce a potential difference between it and its surroundings. See that now? Now, in this electrical field, a charge is given toward a conductor for it to produce PD between it and what? Its surroundings. So that is the essence of having a capacitor in an electric field. So we want to induce and also store this electrical charge. Or sometimes we use it to separate AC current from DC current. So that is the use of capacitor.
It consists of two conductors which are parallel to each other. It is an arrangement of two conductors with equal and opposite charges which are separated by an insulating material for storing charges. The equal and opposite charges are called dipoles, and the insulating material between the plates is called the dielectric. So, in most elementary states, a capacitor consists of two metal plates separated by a certain distance d. In between the plates lies the dielectric material with what? A dielectric constant E, which is equal to EO times E, which is known as what? Relative permittivity. Okay. The dielectric material, why do we need to use it? We make use of it because we want it to allow for charges to accumulate between the capacitor plates. Alright, let us look at the functions or uses of capacitors. How are they used and what are they used for? Number one thing that capacitors are used for, number one is for storing electrical energy in strong electromagnetic or electric field between its plates. So it is used to store what? Electrical energy. That is number one uses of capacitor. Then number two, establishing different electrified patterns. So we use it to establish different electrified patterns in an electric field. That is number two. Then number three, we use it to filter out AC from DC. That is, having low resistance for AC and high resistance for DC. Of course, AC means alternating current and DC stands for what? Direct current. So that is number three use. Then number four, in electronics, to reduce voltage fluctuations, detect electromagnetic oscillations at radio frequencies, provide time delays and transmit paused signals. So this is very important in electronics. So it is a capacitor that will help us to check this. Now, number five thing that we use it for is what? To cancel sparking. Okay, let us understand capacitance. Remember, we are just explaining capacitor. I told you that capacitance is gotten from capacitor. So since we already know what capacitor is, we are storing what? The quantity of what? Charge. So we use it to store electrical charges. Okay, now capacitance now is defined to be the amount of charge Q stored in between the two plates for a potential difference or voltage V existing across the plates. Remember I told you that when you give a charge to a conductor to produce a potential difference in an electric field, that is a capacitance. Okay, now the capacitance we are talking about, or capacity, so is the ratio of the charge on either conductor to the potential difference between the two of them. That is just what capacitance. And now the unit of capacitance is farad. We still have other units like microfarad and picofarad. So the SI unit, the generally accepted unit, is what? The farad. So we will be solving calculations regarding to this capacitance. Okay, now before we do that, let us look at factors affecting capacitance. So what are the factors that will affect the capacitance in an electric field? Number one thing that will affect the capacitance is the area of the plates. So meaning that what? Area is directly proportional to the capacitance. So that is number one thing that will affect it. Number two factor that will affect capacitance is distance between the plates. So the distance is inversely proportional to the capacitance. That is number two. Then number three, the dielectric between the plates, thickness or density of the medium or the insulating material, so is directly proportional to the capacitance. So meaning that what? Capacitance directly proportional to the area and inversely proportional to the distance separating the two plates. So that is where we then have the permittivity as our constant in this case. All right, so in our next video we are going to look at how we can be able to calculate the capacitance, the effective capacitance in the circuits. Right, bye.